Today's lesson is 1.5 Angle Pairs. We're going to talk about 4 special types of angle pairs today. Let's go ahead and get started with our linear pair of angles. These are two adjacent angles. Now remember, adjacent just means that they have to touch each other. They must share a vertex and they must share a common side, whose non-common sides form opposite rays. Remember, when we form opposite rays, we are forming a straight line. This means that linear pairs are supplementary. And we're going to talk about supplementary in just a moment. There we go. All right, let's go ahead and take a look. Here is what a linear pair would look like. I want you to notice that there are two angles. Angle 1 is 112 degrees, and angle 2 is x degrees. Oh, there we go, that's better. And that together, they form a straight line or a straight angle, which we know is 180 degrees. So supplementary, which we're going to talk about soon, just means that if I added these two angles together, the yellow plus the pink, they must equal 180 degrees. Let's go ahead and take a look at our example. Two angles form a linear pair. So let's go ahead and underline that. I know that when I see the word linear pair, I'm going to add the two angles together and they have to equal 180 degrees because that's what linear pair means. The measure of one angle is 3 times the measure of the other. Find the measure of each angle. So here we go. I have angle 1, okay, because I don't know what letters to use, so I can go ahead and call it angle 1. And I'm just going to simply call it X because they didn't really say anything about angle 1. But what they said about angle 2 is that it is 3 times the measure of angle 1. So if I'm going to show 3 times, I'm going to show 3 times X. The rule says the yellow plus the pink equals the orange. So the yellow plus the pink, oh, well, let me put it in blue for you guys. The yellow plus the pink equals 180 degrees. So let's plug it in. X plus 3x equals 180. Let's go ahead and solve. X plus 3x would give me 4x. Because remember, there's that invisible 1 hiding with any x. I'm simply going to go ahead and divide each side by 4 because there's no adding or subtracting to get rid of. So I'm simply right at the point where I'm going to go ahead and divide, which would give me 45. So one angle is 45 degrees. So if I come back over here, I could say the measure of angle 1. Ooh, that doesn't look good. Hold on, guys. There we go. Equals 45 degrees. And to find the measure of angle 2, I'm just simply going to multiply 3 times 45, which gives me 135 degrees. These would be the answers to the question. Let's box them in. There we go. All right, next let's go ahead and take a look at our vertical angles. This is what vertical angles look like. I do want you to notice that they do intersect right here. There are 1, 2, 3, 4 different angles, and that there are 2 lines that cross and make an X. Now, of course, I could move them to be horizontal, but if I simply rotate my screen, I see the X again. But I have to see 1, 2, 3, 4 angles to get vertical. All right, 2 angles whose sides form pairs of opposite rays, or a pair of non-adjacent angles formed by 2 intersecting lines, which is what we see up above. Vertical angles are congruent. Here is the symbol for congruent. It's the equal sign with a squiggle above the top. So congruent means we're equal, but we're like exactly the same. That's what the little squiggle on the top means. When we are vertical, we must share a vertex and we must be on opposite sides of that vertex from each other. So notice they cannot share any sides. This angle here, which is 72 degrees, well, here, let me highlight it. This angle here in pink, which is 72 degrees, does not share anything but the vertex with this angle here, which is x degrees. This is what makes them um, vertical. Notice that this angle here could not be vertical to the pink or to the yellow angle because they share a side. The pink shares right here and the yellow shares right there. So if they share a side, they cannot be vertical. But they have to share that vertex. So let's go ahead and make that a little bit bigger. That's the only thing they share, and they have to be across from one another. Likewise, those two are vertical. These two angles, even though we don't know exactly what they are. Oh, hold on a second. Let me not. There we go. This angle and this angle are vertical as well because they would not share any sides. Okay, let's take a look just so that you can see. This angle and this angle are vertical because they share no sides as well. All right, let's go ahead and take a look at our problem. Angle ABC and angle DBE are vertical angles. So there's no picture because they told us they're vertical. If they tell us they're vertical, then we know that that means that they are congruent because that's what the definition up above says, which means they are equal to each other. Vertical means equal. We're the same. Okay. Find the measures of the angles if the measure of angle DBC, oh, I can make that, there we go, is 7x minus 8, and the measure of angle DBE is 5x plus 10. Remember, vertical means that this yellow angle and this pink angle are equal. We're equal. So let's just go ahead and plug in the yellow piece. There we go, and plug in the pink piece. There we go. Let's go ahead and solve. There's no distributing to do, so let's go ahead and look for like terms. On this side right here, there are no like terms because of the x. I cannot subtract. On this side, there are no like terms because of the x. I cannot add the 5 and the 10. Let's go ahead and take a look at our x's. And let's move the smaller one over to the same side as the larger one. 5 is smaller than 7, so I'm going to subtract 5x because it was a positive 5x. If it had been a negative 5x, I would have gone ahead and added it. That gives me 2x. I'm going to bring down my minus 8 equals, and I did not cross out the positive 10. I can drop the positive though. I must focus over here where my blue X is, and I must get rid of my add or subtract by doing its inverse, which is the opposite. I see subtract, so I'm going to go ahead and add 8 to get rid of it and move it to the other side. Remember, when you're getting rid of stuff, it always goes to the other side. That would be 18. Ooh, I'm getting out of space. Go back to my x. Remember, there's multiplication hiding between a number and an x, so to get rid of the multiplication, I must do its inverse or the opposite, which is division. I'm simply going to go ahead and divide both sides by 2. X is equal to 9. What did they ask me to do? Find the measures of the angles. Let's go ahead and plug it back in. The measure of angle ABC would be 7 times 9 minus 8, which equals 55 degrees. And the measure of angle DBE would be 5 times 9 plus 10, which is also 55 degrees. You should get the same answer. You should get the same answer because remember, vertical means we are equal. Vertical means congruent, which means we are equal. All right, let's talk about those two that you've probably heard before, complementary, and then we're going to talk about supplementary angles. Complementary angles are two angles with a sum of 90 degrees. They can be adjacent, which means they can touch one another, just like here in the picture. Take a look at my picture. Let me go ahead and do this. This is what adjacent looks like. They share a side. So take a look here. Here's angle 1, it's 15 degrees. Here's angle 2, it's X degrees. And I know that they are complementary because of the 90-degree box right here. Okay, so 15 plus something has to equal 90 degrees. Or they could be non-adjacent, which just means that they don't have to touch each other. Oh, where'd it go? There we go. Let me show you what that would look like. So we could have an angle, say here, and it could be labeled, say, let me make my pen a little smaller, 50 degrees. And then we could have an angle over here. There we go. And it could be labeled as 40 degrees. Notice that these two angles would be complementary to one another because 50 plus 40 equals 90. They share nothing, so they are non-adjacent. Okay, let's go ahead and take a look at our example. In our example, angle LMN and angle PQR are complementary. So let's go ahead and underline complementary. Oh no, wait, let me use purple. Actually, no, I use purple to be equal. Let's go ahead and change it to pink. Complementary, which means I'm going to take my two angles, I'm going to add them together, and they have to equal 90 degrees. One quick way to memorize it is to look at the letter P. Okay, and I'll give you a hint about that when we get to supplementary. But one quick way to remember which one's 90 and which one's 180 is to look at the P, and I'll show you that in just a minute. Find the measures of the angles. If the measure of angle LMN is 4x, oh, sorry, 4x minus 2, and the measure of angle PQR is 9x plus 1. Because we know that they are complementary, we know we're going to take our two angles, we're going to add them together, and they have to equal, there we go, 90 degrees. They have to equal 90 degrees. Let's go ahead and plug them in. There we go. And let's go ahead and solve. No picture is necessary because the word complementary tells me what to do. I don't need a picture because the word complementary tells me what to do. Let's go ahead and take a look. There's no distributing to do, but there are like terms to combine. I'm going to combine together my 4x plus my 9x, which does give me 13x. And I am going to combine together the negative 2 and the plus 1, which would give me minus 1 equals 90. I cannot, there are no, oh no, I did my combining my like terms. There's only the one variable x and it's already on one side, so I can skip that step. Look right over here. I'm going to get rid of my addition or subtraction by doing the inverse or doing the opposite. I see minus, so I'm going to go ahead and add 1 to both sides. Remember, when you're crossing stuff out, it has to go from one side to the other. That's why the line through the equals is so important. Remember, we're getting rid of the number in front of the x, and our last step should almost always be to get rid of multiply, even though it's multiplication or division, by doing the inverse. The inverse of multiply is, of course, divide. So I'm just going to simply divide by 13. And 91 divided by 13 is 7. Okay, if I go back and plug it in, I'm going to get the measure of angle LMN is 4 times 7 minus 2, which is 26 degrees. And the measure of angle PQR would be 9 times 7 minus 1, which is 64 degrees. Oh, plus 1. There we go. I was like, no, that's 62 because 9 times 7 is 63. Ah, there we go. There's our answer right there. All right, our last angle pair that we're going to talk about today are supplementary angles. Supplementary angles are two angles with a sum of 180 degrees. Once again, they can be adjacent, and I'm going to show you what that would look like. Adjacent would mean you see a straight line that is split with a ray, and you have angle 1 and you have angle 2. They're split here at a point. Okay, that's what adjacent would look like. Or they could be non-adjacent, which is what these angles are right here. Oops, that did not go the way I planned. There we go. Which just means, notice that these two angles do not share a vertex. Angle A and angle B, they do not share a vertex, and they do not share a common side. Neither one of them share a common side. But it says right here that they are supplementary, so I know this angle plus this angle has to be 180 degrees. That's what that is telling me. All right, let's do our last example. The measure of the supplement of an angle is 36 degrees less than the measure of the angle. Notice I'm seeing that word supplement. Supplement means, supplement is just another form of supplementary, and so it means I'm going to take my two angles, add them together, and they have to equal 180 degrees. So let me show you the trick. There are two letter P's in the word supplement or supplementary. The letter P looks like the number 9. So these P's are telling you how many 90s are in this angle pair. So there are two 90s here, 90 plus 90, 180. If you go back to complementary, there's only one P in it, complementary, and so it would just be 90. It's just a quick way, a little way to help your brain remember. All right, find the measures of the angles. All right, here we go. So I know that angle 1 plus angle 2 has to equal 180 degrees because of the word supplement. Okay, so I know that this is true. I've just got to figure out what to put for angle 1 and what to put for angle 2. All right, I'm always going to call angle 1 in this situation X, because one of the angles, they're going to tell me nothing about it, but they're going to compare the other angle to it. So I can always call angle 1 X. So I'm going to call this one X. Remember, there's an invisible 1 with it, so I'm going to go ahead and add that to it. Then it says, the measure of the supplement of an angle is 36 degrees less than the measure of the angle. Well, the measure of the first angle is X. Less than would be minus, and the 36 has to go behind it because less than, remember, says it's subtraction and the number goes behind. So X minus 36. Remember, there's an invisible 1 with it once again. We're ready and we can go ahead and solve. I'm going to go ahead and combine my like terms because there is no distributing to do. 1 plus 1 would be 2x. And then I have my minus 36 equals 180. I'm at the point where I'm going to go over here where my x is, and I'm going to get rid of my plus or minus by doing its inverse. I see minus, inverse means do the opposite, which is plus 36. 180 plus 36 is 216. I'm going to go back over here to the side where my x is. There's multiplication hiding there. I need to get rid of it by doing its inverse, which is division, because that's the opposite. Divide by 2, divide by 2, x equals 108. There we go. Now find the measure of each of them. Well, this angle, the measure of angle 1, where can I put this? The measure of angle 1 would be 108 degrees, and the measure of angle 2 would be 108 minus 36, which would be 72 degrees. All right, I have two final examples for you, just to see if you can use your foldable that we did in class today. So example 1, ray CD. Uh-oh, I haven't seen this symbol. This symbol right here is the symbol for perpendicular. For angles to be perpendicular, they must have a 90-degree angle. For angles to be perpendicular, they must create a 90-degree angle. Or for rays to be perpendicular, they must create a 90-degree angle. So I'm thinking this one is going to do complementary because that was my one that they added to 90 degrees. So I'm going to open up that flap to help me finish this problem. So CD, ray CD, is perpendicular to line AB. That means that there's a 90-degree angle right here. There we go. So I can put the 90 degrees right there. The measure of angle 1 is 6x minus 3 degrees. I can go ahead and drop the parentheses. There's just telling me that when I substitute back in, or if I'm asked to substitute back in, I have to put the x in and multiply by 6 and then subtract by 3. That's why the parentheses are there. And the measure of angle 2 is 7x minus 11. Once again, I can drop the parentheses. They're not there to tell me to distribute. Find x. If I go and look, I remember this angle, and it doesn't matter if it's angle 1 or angle 2, it doesn't matter, plus this angle has to equal 90 degrees. That's what perpendicular, that's what complementary means. These angles have to be complementary to one another, right? To be, let me see, let me show you, to be this one, right? Well, no, we don't need that. There we go. So the yellow plus the pink has to equal 90 degrees. Let's plug in the yellow and let's plug in the pink. Now, could you switch those two? Yes, yes, you can. Yes, you can. You can switch those two. So remember, we talked about that we don't have to combine like term, or there's no distributing to do because these parentheses did not mean to distribute. We're going to go ahead and combine our like terms. So I'm going to go ahead and add my 7x plus my 6x, which gives me 13x. And then I'm going to go ahead and combine the negative 11 minus the 3, which gives me negative 14. Remember, you can leave them separate. You can leave them separate and then take care of each one. All right, we're focusing over here where our x is. Actually, we need to check to make sure we only have one x and it's on the same side. So yes, we do. We have to get rid of our minus because that's what I see, add or subtract. I see subtract by doing its inverse, which is its opposite. So I'm going to go ahead and add 14 to the other side. You guys are getting awesome at solving a two-step equation. It's just that mix of getting it to a two-step equation. That would be 104. Remember, there's multiplication hiding in there. So if you're going to get rid of the multiplication, you must do its opposite, its inverse, which is division. Remember, you're always dividing by the number in front of the variable x, and that would give me 8. You can go back and check it by plugging it in. Remember, if you're asked to plug in, I didn't on this question, you would for this angle do 6 times 8 minus 3, and here you would do 7 times 8 minus 11, and that's how you would get your two angle measures. All right, our last question for today is find the measure of angle EBC. I'm going to grab my highlighter. And I'm going to help me find angle EBC. I'm just going to follow in order from E to B to C. This is the angle that they are asking me to find. So I'm going to go ahead and do this and put a question mark. I need to figure out this angle. Now, the two angles that were given to me are this angle here. Let me put them in yellow and pink. This angle here, ABE, and this angle here, DBC. I've got to stop and think, what do I know about the yellow angle and the pink angle? What do I know about the yellow angle and the pink angle? Let's go back to our foldable. Let's go back to our foldable. So in our foldable, I'm going to take a look at the outside. And if I look at the pictures on the outside of my foldable, it really looks like the vertical angles. I'm going to go back to that part of my foldable, and I'm going to flip it open, and it's set, and it looks just like it. They've been moved, but this angle and this angle are vertical because look, they're sharing that B. In our foldable, the two angles that were marked as vertical were here and here, right? But remember, we talked about the ones above and below were equal as well. So I'm going to go ahead and set them equal because vertical angles are congruent, which means they are equal. Let's go ahead and plug them in. Now remember, you don't need the parentheses because the parentheses are there for substitution purposes to find the degree, to make sure you substitute in and do everything, not just 2 times whatever x is. You have to do 2 times x and then add 20. Same thing here. I can drop the parentheses because they're really there for the purpose of finding the degree of the angle. Let's go ahead and solve for x so that we can find that orange angle. All right, I do not see any distributing because remember we talked about the fact that these parentheses are not distributing parentheses, they are parentheses for substitution purposes. Next would be combine like terms. I cannot add 2 plus 20 because the 2 has an x and the 20 does not. Likewise over here, I cannot add 3 plus 15 because the x has a 3 and the 3 has an x and the 15 does not. So let's go ahead and get our x on one side. So on the left side, I have 2x, and on the right side, I have 3x. It is my choice which one I move. I like to move the smaller one. 2 is smaller, so I'm going to subtract it to move it. Just like that. There we go. Which does give me 1x. It leaves me 20 on this side, and then I have to bring down my plus 15. All right, I'm focusing over here where my blue 1x is. Remember, the 1 does not need to be there. It can become invisible. I need to get rid of my add or subtract. I see add by doing its inverse, which is its opposite. The opposite of add is, of course, subtract. Remember, the 1 can become invisible. 20 minus 15 is 5. The 1 can become invisible, which means I am done with my problem. It's okay if you leave the 1. Remember, if the 1 was there, you'd have to divide by 1 to get rid of the multiplication. And if I divide by 1, I still end up with x equals 5, so it doesn't matter. All right, but I need to find the measure of this angle. A good thing to do is to take my answer and substitute it back in either into the yellow or the pink, whichever one I would think is easier. I'm going to do the yellow because for me, I don't know why, I just think it's going to be easier than the purple, the pink one. So I'm going to go ahead and I'm going to say, let me 2. Ooh, hold on. 2 times 5, which is 10, plus 20, which is 30 degrees. So this angle is 30 degrees. Likewise, this angle is 30 degrees. They have to be. And 3 times 5 is 15. 15 and 15 is 30. That wasn't so hard. I could have done that. It doesn't matter. But now I have to think about what's the relationship between this yellow angle. Oops. Oh, no. There we go. What's the relationship between this yellow angle and this orange angle that they want me to find? Well, let's just focus on them. So let's pretend that none of this exists. If none of this exists, take a look at this. This is what I have. Let's look at our foldable. If I look at the foldable, this looks like 2 of the pieces of my foldable. So let me do that again. Get rid of this. Here's what I'm focusing on, right? Okay, this looks like 2 parts of my foldable. It looks like the linear pair and it looks like the supplementary angles. Either one of these will get the job done. I can flip up either one. Now, technically, this is a linear pair. Technically, this is a linear pair because they are connected together at the point B. Okay, linear pairs just happen to be supplementary, which is why the picture looks the same. But supplementary angles do not have to be connected. So it would be okay to call these 2 angles supplementary, but their more proper term would be linear pair because they are connected together through the point B. Either one, I flip them up. I know that this angle here plus this angle here has to equal 180 degrees. So in order to find the measure of angle EBC, I'm simply going to take 180 degrees and subtract the 30 degrees from the yellow. So where did I get this 30? I got it from the yellow angle when I substituted, which gives me 150 degrees.